Hello, welcome to this new video from Guidancee Education channel. In this video, we will be discussing dimensional analysis, principle of homogeneity, introduction to applications and limitations of dimensional analysis. In the next video, we will discuss applications and limitations of dimensional analysis in detail. Analyzing a physical equation and then understanding the dimensions of the physical quantities present in the equation is called dimensional analysis. I have already posted a video on dimensions, dimensional formula and dimensional equation. I have also provided a worksheet in that video. If you have not yet watched that video, click the I button on the right hand top corner of the video in order to watch it. But before we proceed, watch the video completely so that you get all points cleared. And if you think the video is useful, like the video, share the video and also leave your comments in the comment box below. If you have not yet subscribed my channel, do subscribe my channel now and also press the bell button near it so that you get intimated as soon as videos are posted. Now let us continue. We will consider three physical formulae in order to understand dimensional analysis better. Let me note it here. T is equal to 2 pi root L by G. This is the physical equation for calculating time period of a pendulum. What are the physical quantities in this equation? Time, length and acceleration. Next one. Energy is equal to mc square. What are the physical quantities? Energy is nothing but work done and it is equal to F into S. F is equal to ma. Therefore, mass, acceleration and distance on left hand side. Mass and velocity square on the right hand side. C is the velocity of light in vacuum. So many quantities are there in this equation. Third equation, S is equal to ut plus half at square. This is the equation of motion for displacement. The physical quantities are S, displacement, initial velocity u, then time and acceleration and t raised to 2, that is time raised to 2. Let us take the first case. We have already stated the dimensions. We will make a representation. Dimension for time is t. 2 pi is a constant. It has no dimension. So, t is equal to root of L is length. So, L by G is acceleration due to gravity. So, L by L t raised to minus 2. So, these are the dimensions in this equation. This is called dimensional analysis. Dimensional formula and dimensional equation are written on the basis of this dimensional analysis. Okay, we will take up the second one. We have to consider all these quantities. M for mass, L t raised to minus 2 for acceleration and then L for S is equal to m c square velocity square. Velocity is L t raised to minus 1 raised to 2. So this is the dimensional analysis for this equation. What about the last one? For S, it is L, initial velocity L t raised to minus 1 into t plus half has no dimension, acceleration is L t raised to minus 2 t square t raised to 2. So these are the dimensions for this equation. So this is called dimensional analysis. Okay. This principle is used in the three applications of dimensional analysis. What does it state? Let us note down the statement. Principle of homogeneity states that dimensions of the same physical quantity must be the same on either side of the equation. Homogeneity means same. What is same here? the dimensions of the physical quantity on either side of the equation is same. Let us take the simplest equation here. E is equal to mc square. Consider the dimensions on either side of the equation. On the left hand side there is mass. On the right hand side also there is mass. On the left hand side there is L into L. There is L raised to 2. On the right hand side also there is L raised to 2. Then on the left hand side there is T raised to minus 2. On the right hand side also T raised to minus 1 raised to 2. That is T raised to minus 2. So the left hand side and right hand side are in perfect agreement. This is the principle of homogeneity. So this equation is dimensionally correct. Checking the validity of the physical equation is one application of dimensional analysis. We will see that in detail in the next video. Now let us see the applications of dimensional analysis and then proceed to its limitations. What is the meaning of applications of dimensional analysis? By this term we mean the uses of dimensional analysis. In which fields this dimensional analysis is used? There are three applications. First one, to check the correctness of a physical equation. A physical equation is correct if only it is dimensionally correct. That is, the dimensions of the physical quantities on either side of the equation should be the same. Second one, derive the general formula of a physical quantity. In order to derive the general formula of a quantity, we have to know the dependence of that physical quantity on other physical quantity. For example, we want to derive the general formula for energy. Then we should know that energy depends on mass and velocity of light. Dimensional analysis can be used to convert the unit of a physical quantity from one system to another. Say for example, we want to convert the unit of force from SI system to CGS system or vice versa, then this method can be used. The only thing is we should know the dimensions of the physical quantities as suggested by the unit in both systems. We will discuss these applications in detail in the next video for better understanding. We will do examples for these three cases. Okay. Now let us see the limitations of dimensional analysis. What do we mean by limitations? Though it has three applications, these three applications are not universal. In certain situations, these applications do not work. That are its limitations. Let us see what they are. If an equation contains dimensionless quantities like angle, constants, trigonometric ratios, etc., then this method cannot be applied. If an equation contains exponentials and trigonometric functions, then this does not apply. If the physical quantity depends on more than three quantities, then this method cannot be applied. The last one, if the true relation contains sum of two or more quantities, then also this method cannot be applied. Generally, in your examination, questions are asked only with reference to applications, that is, cases where this can be applied. Cases where this cannot be applied is not generally asked for the examination. You will be only asked to mention the limitations, then you should be able to do that. So practice this well. Okay, in the next video we will discuss the applications in detail with a few examples worked out. That will help you a lot in attempting questions on this topic. Thank you very much.